Can you hear things now? Do you? Yeah. Oh, ooh, yes. Wait, does the yes mean you can hear now?
Okay, now is anything happening now?
Yes.
Yes. Okay.
Yes.
Stan is back.
Yes.
Injected is back.
Oh my gosh.
Vinroy, Luo.
We're just getting the band back together.
Oh my goodness.
Vinroy's on drums.
We have had a terrible 2 weeks.
We've been crying nonstop. Yes, we're back.
Awesome.
Yes, we are.
Okay. You're definitely the first, Alwayne, for sure.
Yes, definitely.
So it's good to be back. We planned nothing because we did not think this was going to work.
Yep. If you fail to plan, you plan to fail, which we did. We completely planned to fail here.
Well, we actually planned to not have any issue with Spectrum Internet, and that was a poor plan.
Yeah, it was a poor plan.
Yeah.
But we fixed it through brute force of will.
And at least, I would say I've probably spent about 6 hours on the phone with Spectrum over the last 2 weeks in total.
Well, they convert that into better internet coverage. You have to spend 6 hours, though. It's got to get up to that 6 hour mark. And then suddenly, bam, internet just next level. Okay, you guys. Is there anything in particular that you'd like us to talk about? Brendan's not here, so we could talk very, very in-depth on Brendan's personal life.
Oh, yeah. We are really excited to be back, so please throw questions at us.
Polynomials.
You got that? I'm going to look at the Discord.
Man, I have polynomials.
You have
Yes. Is there anything in particular about polynomials and quadratic inequalities? Oh, okay. All right. Yes, please post any of your questions in the Discord, and we'll take a look at those. I can probably just kind of go for it here. Let's see if there's anything recent. No, there's not. Okay. Let me pull up UWorld. Ellipses. Okay. All sorts of things. Yeah, go ahead and pull up UWorld. That should be fun. Let's talk about this. Quadratic inequalities. So, we'll say something like this. Y is greater than or equal to x squared plus 7x plus 12.
I'm in such a good mood.
Are you?
Yeah,
you gotta calm down, man.
Finally.
You gotta calm down. You gotta calm down. Okay, so graphic inequalities. One thing you should ask yourself, will it be a line or will it be a dotted line? This here is greater than or equal to, so it can actually be found on the line, which means we want a solid line. If it was just y is greater than, then we'd only want a dotted line. We want a solid line here, okay? Let's put the solid line where it would be, which is at this parabola right here, okay? So graphing parabolas is a lot of fun. First thing, we have a positive leading coefficient. Whatever's in front of the x squared tells us if this thing's going to open upward or downward. This is a positive x squared. It's going to open upward. The next thing we want to look at is our y-intercept. Was that donation bar always there? No, it was not, Stan the Curry man, but it's there now.
Curry.
No, Curry has 2 R's.
Yes.
Yes, that is just officially the best of my life. That's so nice. That's so nice. Yeah, no, Bob kind of destroyed it all, really. That was the last time it all worked. Yes, it was Bob. It came with Bob. So anyway, y-intercept, where we cross the y-axis. Whenever you hear y-intercept, you want to think to yourself, x is equal to 0. When you're crossing the y-axis, anywhere along that line, your x value is equal to 0. Okay?
Wait, how did it get there?
Oh, like that. Okay? So if our x's are all zeros, the only thing we have left is 12. That is our y-intercept. All right? Put a little 12 right there. This is identical to how it works in slope-intercept form. When you have y is equal to, let's say, 4x plus 12. 12 is your y-intercept because that's what happens when x is equal to 0. Vic Sweet, yes, we are. We are back. And we're better than ever. We've all just been hitting the gym every single day, just getting jacked, and now we're ready to teach at a light board, which is what people should get very strong to do. Okay? Yeah, same deal. If x is 0, then y is going to be 12. So this floating constant at the end will be our y-intercept. We have a y-intercept of 12 here. Okay? Next thing, our x-intercepts. Our x-intercepts happen when our y is equal to 0. So there's some symmetry going on here. Your y-intercept happens when x is equal to 0. Your x-intercept happens when your y is equal to 0. Okay? It's a lot of fun. Just, if you're bored on a Sunday, think about it. Only on Sundays, though. So, in order to find the x-intercept, we set y is equal to 0. 0 is equal to x squared plus 7x plus 12. And this is what solving a quadratic equation. Do college interviews have trick questions? No. No, they don't. You should be answering these questions honestly, being yourself. As cliche as that sounds, but there's no trick questions. Solving a quadratic equation, what are the x values that make this equal to 0? Factoring will work here. We're looking for two numbers that multiply. I always do a little m. Multiply to 12 and add to 7. Those two numbers are 3 and 4. So our factors are x plus 3, x plus 4 is equal to 0. If those are our factors, our solutions are -3 and -4. Those are x-intercepts right there. Remember, had a 2-hour college interview the other day. That's good. That's a good sign. That means that they wanted to keep talking to you. Or maybe they're just required to. I don't know. X-intercepts, solutions, roots, zeros, all the same thing. That's what these numbers are right here. So it goes through -3 and -4, which is probably going to be right there and right there. That's -3 and -4. All right, we have enough now to kind of ballpark what this parabola is going to look like. Hi, Brady. Hi, Levi. Have fun without me this week. Oh, we will. Ha, ha, ha. We will. Anyway, Brendan, it's been working the entire time. We just wanted to make sure that it wasn't working whenever you were here. So now that you're gone, it's working again. Oh, God. Okay, good. I'm just kidding, Brendan. You know, we're starting a company together. We can't... It's all that stuff. So, parabola here, it's going to go up, and it's going to go through these x-intercepts. So I can just kind of, let's see what this thing's going to look like. Something like that. Woo! Okay. Other things you could look for are what the axis of symmetry is, what the vertex is. That's kind of not really what your question was, though. Rip me, I guess. Yes, rip you. Rip you to shreds. Although that'd be impossible because you're made out of titanium. So now it comes... What?
Traps.
Your traps are made of titanium. I think Brendan is made out of exclusively traps.
Yep.
I think he's put together from the traps of much stronger men. 25 to a 29, not too shabby, Stanley Curie, man. 4 points is...
Yeah.
That is a thick increase.
That is a very thick increase.
Yes.
A thick 4. Ooh, we can do a little bit of
put on the cue? Anyway, coming back to polynomial inequalities, now it comes time to do the shading. Which side do you shade, okay? The easiest thing to do here is take a look at your inequality. Y is greater than or equal to. Y represents the height of the point, so the height of the point has to be greater than the line. This means shade upward. If you have greater than, you shade up. If you have less than, you shade down. So everywhere on this line, we want to be shading upwards, which means if you pick any point on this line and shade upwards, you're going to be on the inside of the parabola, okay? This is where the shading is going to happen. You're on the inside of the parabola. Other teachers often ask you to put in a test point to see if the test point works or not. A really nice test point to use is the origin, 0, 0. If I put 0 in here for x and y, we're going to get 0 is greater than or equal to 12, which is not correct. Therefore, this test point doesn't work, so it's not the outside that we want, it's the inside. That's what we want to shade. What are you saying about me? Brendan, you're made out of traps. That's what we're saying about you. Yes, but your own traps are... I guess your own traps. But every other part of you is just some other poor...
Someone else's traps.
Man's traps. Exactly.
Have you ever noticed that if you look at a picture of
Brendan?
a really, really muscular person...
Yeah.
It looks like a very thin person. Their shoulders inside some giant person's shoulders.
Oh, yes. I've noticed that, yeah.
Stuck right in there.
Yeah, and once you put them in there, like, there's no coming out.
No.
Yeah,
no,
it's such a tight fit.
Well, it's a vacuum.
It's a
vacuum seal.
Exactly. They're not coming out. Maybe Brendan's like that.
Yeah.
I don't know.
Look at this small man.
He's just a tiny, shriveled man inside of a big, strong guy outfit.
That's the nerd in him. Just stuck.
It all makes sense now. It all makes sense. I almost picture him as just like, he's like a head with like a root. Just like,
oh my gosh.
You know what I mean?
Yes, I do know.
He's not a tiny man, it's
horrifying.
just a root. And so you put it inside the body.
You know, this conversation right here is why Stan did so much better on the ACT.
Probably.
Yeah.
SSJ Purvis. Hello.
Purvis, hey, what's up? Welcome back.
Welcome back.
Well, I guess you should welcome us back. You have all been around. We have not, so we apologize for that.
We're the ones in trouble. Hey, we got some problems on the Discord.
Yeah, I got... And this one is actually a good one to hop off of from here. So I think we probably need to be able to erase things.
Oh, this is fantastic. We have problems. We've been so hungry for problems.
Oh, so hungry.
The hungriest. Hey, we got some bits.
Thank you.
I've been
for
pretty
the bits.
hungry. Speaking of hunger.
Yeah, boy. Thank you for the bits. We really appreciate it.
Good. Those were great bits. Keep me going for at least a couple minutes before I'm going to need my next bit infusion. This feels good.
It does. It feels really nice.
Feels good.
Vix, we'll get punctuation in a little bit. I think this is Luo's question. Oh my gosh. The chat is so colorful. Guy, thank you for the resub. 2 months? What?
Well done, Guy. Well done.
Oh, man.
I haven't done that in a while.
Yeah, because we haven't streamed in so long.
Oh, that's why.
Yeah.
Okay, I had no idea why I wasn't doing it.
You hadn't thought about that.
Like, I did not make the
asked
connection that's when I do it.
Boneheaded question.
Right. 2 months in a row. Wow. That's fantastic.
For those of you who didn't understand this motion, that's a positive thing.
It is a good thing.
Brady.
Yeah, for me specifically.
Okay. So I'm going to do Luo's question. Can you write up
Absolutely.
the inequalities?
Yes, I can. Okay. So, did Luo post 2 questions?
Yeah, you know what? I'll write up the inequalities.
Sounds good.
If you want to get started on the next question over there. Or something.
Injected? Or
Yeah, the
okay.
non-Luo question, I guess.
Yeah. I like
So we
that.
this is 2 inequalities, and we have f of x, so it's y essentially, is less than 12x, or negative 12x plus 20, or 120, sorry. And then g of x is also less than 4x plus 40. Okay. People freak out with inequalities, so that can happen. And we want the maximum possible. So xy is the solution to this. So we're finding the solution of this system of inequalities, and then we're trying to find the maximum value. So max value of xy that satisfies this thing. Okay, pretty confusing. This is not a super common question, but what we're going to do here is we're going to graph. That's what we're going to do first. This is a very visual problem, I think. So let's see. We'll do pink. Now, we got to get shirts.
No.
Oh, right. In this case, we have the negative 12x plus 120. So I'm going to graph that. We're going to go up 120, and then it's going to be a negative 12x. So it's going to look something like that. That's our line, and it's less than or equal to, so it'll be a solid line. It won't be dotted. That's the first one. So this is f of x here, and then g of x will be there. So this is f of x, and g of x is 4x plus 40. So if this is 120 here, and this is 40 here, then we're going to have something like that. So this will be g of x. Now, we're doing less than both of those, less than or equal to both of those. So we're going to shade in here for f of x, because we're less than that one. And then we're going to shade in here for g of x, because we're less than that one. So, hope you can see this, probably not that well. This right here is our solution stuff. All of this in here, okay? So this point is going to be the maximum value. We want the maximum xy value, probably the maximum y now that I think about it. Otherwise, this question would be a little bit confusing. Do you know? Ulu or Luo, does this make sense so far, what I've done? I hope you can see where the solution set is. Oh, look at all these questions, Brent. Your name. Yeah.
Yes, my
Whatever
name.
that is.
That is correct.
Yep. What is the maximum possible value of y? Okay, so what's the maximum y value? In this case, it actually ends up just being solving a system of equations. Luo, and it was Luo, right, who posted these? Yeah. Luo. Yes, okay, so it makes sense so far. We need to find this point because we're looking at, this is a solution down here, this is a solution over here, this is a solution here, this is not a solution, not a solution, not a solution. It has to satisfy both inequalities. And now we want the greatest y value. So the highest y value is going to be at this point where the two lines intersect. So what we're going to do is, this is just y and y. So we're going to set the lines equal to each other. So we have y equals negative 12x plus 120. And we also have y equals 4x plus 40. You solve this as you would solve a normal system of equations. And the resulting y value that you solve for will be the answer to this question. So it made sense so far, and now does it make sense totally far? This is an unusual question, but you can get something like this. This is the type of question I like on UWorld for sure, because it's a little bit esoteric, but all of the same skills that you do need for the test are used in this question. So if anybody watching doesn't understand this or wants me to clarify something, please let me know. We graphed it. Graphing is good. It allows you to see things visually, outsources the work to the paper. Good.
Get it.
How do I pass the time while waiting for my early action decisions? Just sit there.
A lot of repressing,
Yep.
a lot of dissociating.
Yep, that's
Just
true.
do both those things, the time will pass like that.
Mm-hmm.
Time passes really fast when you're dissociated.
Yeah?
Yeah,
Does it?
absolutely. Yes.
Okay.
Very, very fast. It also feels like it goes backwards sometimes.
Ah.
Yeah. No,
But
it's
then
not
if
good.
that's scary, you just also...
Yeah, you didn't dissociate enough.
Yeah.
Exactly. Yeah.
Very
Okay.
good.
So, terrible psychological advice aside, we're going to go to the injecteds question now about an ellipse. So, based off of this equation, first thing to point out, the center of this ellipse. Okay, it's just like the equation for a circle. You're subtracting the center coordinates from x and y. So the center of this ellipse is going to be +3, +5, which you could probably eyeball out on this ellipse. +3, +5. There's our center right there. Fantastic. Next thing is I call them horizontal and vertical radii. What they're supposed to be called is the semi-major axis and the semi-minor axis.
Where did you hear that from?
What?
Like, where did you learn those terms?
Horizontal and vertical radii?
No. The
Semi-major and all that stuff?
Yeah, the radii one. Horizontal and vertical radii. Was that in high school that you learned that? Because I just never heard that.
I made that up myself.
Oh, you made it?
Yes. Because
Ah.
I find them far more simple to think through. Okay.
Wow.
So, just a little refresher. Formula of an ellipse. Injected, this is for you, by the way. I'm going to write this right here. Perfect. X squared over a squared plus b squared. No. Sorry.
No.
Plus y squared over b squared is equal to 1. Where a is the horizontal radius.
What about h and k?
I'm just going to make it centered at the origin right now.
Right.
Horizontal radius and b is the vertical radius. So this should make sense. In this case, our a squared is 9, therefore our a is 3. Our x radius, our horizontal radius is 3, and again, taking a look at this thing, it looks like that's right about correct. We're at an x value of 3, and so if we go back 3 units, we get to the y-axis, and we'll probably go forward 3 units, we'll get to our other... these are the vertices, these are the co-vertices, I believe. That's what they're called. Brennan's kind of our ellipse guy, so you can correct me on that if he's still watching. Anyway, now the y radius is 5. We're going up and down 5. Okay? Your foci are the points on an ellipse that basically create the ellipse in the first place. The way that an ellipse works is oh my gosh. The way that an ellipse works is it is a collection of all the points that the distance of the two foci to those 2 points forms a constant. So a plus b is equal to c. This c is constant. Every point on this ellipse, if you add up the 2 distances from your 2 foci to that point, so this, I'm going to call this c and d. Well, I can't call that c. Okay, so d. D and E also have to make c. There's some great animations on YouTube that explain what's going on here. But if you have like a rubber band and you've got these 2 pegs, forget a rubber band, that's flexible. A string and you've got these 2 pegs, you can move the string around, but it's still going to be connected to these 2 pegs. It's going to carve out an ellipse. So one thing to notice here is that the foci are on the midline of the ellipse and they're oriented in the direction that the ellipse is oriented in. This is a horizontal ellipse, all right? Ellipses are either vertically oriented or horizontally oriented, and the foci are going to be on the midline vertically of a vertical ellipse, and they're going to be on the horizontal midline of a horizontal ellipse. This is a vertical ellipse. So our foci need to be somewhere vertically aligned on this axis right here. Not this axis, but this line. This line here is x is equal to 3. All of these points up and down, we don't know where our foci are going to be, but I'm just going to, ballpark them right around there. They both have x values of 3, so we can get rid of a couple of these options. A is gone because we need to have two x values that are both 3. Another we can eliminate is E. E has a second focus that has an x value of 6, and that's not cool.
Foci.
Foci is Foci-men. It's not.
Foci and
that's not
Fotron.
correct. No, it's the Foltron.
Fotron.
Fotron. Okay. So next thing, the foci are inside the ellipse. They're not on the endpoints or the vertices of the ellipse. Okay. So 3, 0 is not an acceptable place to have a focus.
Hey Jerry.
It's not going to be on the very end of an ellipse. So 3, 0 is down for the count as well, leaving us with only one option. So you actually did not need to know the equation to find the focus of an ellipse for this problem, as long as you understand visually where an ellipse goes and where it doesn't go. Now, there is an equation that helps you find the distance from the center point to the foci. Foci. No, it's focus and foci, I'm telling you. It's c squared equals a squared minus b squared, okay? Where you take whatever is the larger of the b squared and the a squareds, and you subtract, and then it looks almost like the Pythagorean theorem. So if you plug that in here, we have c squared, am I off the screen? No, I'm not, is equal to 25 minus 9. Therefore, c squared is equal to 16. C is equal to 4. So our two foci are 4 units away from the center. It's not foci. It's not. It's not. So we go 4 units up, and we're going to get to a y value of 9. That's a y value of 9. So the point is 3, 9. Go down. This is going to be a y value of 1. So 3, 1 and 3, 9, which is our answer in the first place here. This one. Injected. Please let me know if any of that did not make sense. And if it did make sense, don't tell me a word. Just stay silent.
Silent boy.
He said stuff. / she said stuff. I don't know. Fortlight's got a good question for you.
Why did I take down my website? I took it down a while back. Maybe it was hanging around because of the month subscription that I had, but I took it down because I don't need it. It was good timing, though. I was surprised that you got a photo from it, and I'm very sorry that you can't get more. Okay. Do you think they bought the meaningfulness and what am I saying? The genuineness in my voice?
What do you call a blind dinosaur?
You have tons of downloaded photos of me? Jeez. What do I call a blind dinosaur?
Yeah.
A blindosaur.
No. Do you think you saw us Rex? I didn't make it up. It's from Jurassic Park, I think.
Is it really?
Yeah, or something like that.
Stuff's not real, man.
Jurassic Park?
Yeah.
Then how did they get the footage for that movie?
That is a good question.
Do you have any more bad riddles? I don't think I had a single bad riddle to start, so I don't know how I could have more of them. I have plenty of good riddles.
Okay. I'm not going to go through all of these Vicks. And was Vicks the one who asked for punctuation as well?
I don't know.
We'll do math for a while, then we'll come back to punctuation later. For this one, if you have radicals and you have... good, Vicks, thank you. What are you doing?
Uncle Bill, thank you.
Thank you, Uncle Bill. We really appreciate it. I've been in a bad mood for the last 2 weeks, for sure. Okay. Radicals, exponents. They mean the same thing, and at least for me, and I think for most of the students I've ever had, exponents make more sense logically, so that's where we want to go. There's a lot of work to put these in certain ways. What I like to do is just put them all in x raised to some power, this is some power here, times y raised to some power. If you put all of your options into this format, you will have your answer. The two things that you're trying to equate will be the identical terms, okay? And it doesn't actually take that long, because as long as you're very familiar with your exponent rules. If you're not very familiar with your exponent rules, then yes, this will take a while. But don't do that, or practice, and you will be able to do this very quickly. So we need to get rid of, we don't want the fraction because we want to get to here. So we're going to keep this up top, and we're going to put this one up top. So with just x's, we're going to have x to the negative 2, and then we are dividing by x to the 1/3, which means we're doing subtraction, right? So x to the negative 2 equals x to the negative 2, or this is, let's do this, equals x to the negative 2 minus 1/3, which equals x to the negative 7 over 3. So that's our x term. We're going to do the same thing for y. So we have y to the 1/2 over y to the negative 1. That'll give us y to the 1/2 plus 1 equals y to the 3/2. Should be a positive 1/3. Ah, yes. I don't know why. Didn't actually do that right anyway, so thank you for that, Fortlight. Yeah, so this still is the same. Yeah, that's fine. And then here we have y to the 3/2. So the original expression, wow, I'm so bad at doing tutoring now because I haven't done this in a while.
It's okay, you're rusty.
Yeah.
You're rusty.
Gosh, I just haven't said all the words. That's true. So this one, the original is going to be x to the negative 7/3 y to the 3/2. So that's what we're going for. And now we just take all of these and put it in the same direction. Now we don't have an x in a, so a is just wrong. So there's a lot of ways that you can just make this a very fast process. Once you have your original, or one of them, then you can compare everything else to it. This doesn't have any x's. That's x to the 0, so that doesn't work. And then here, it looks actually pretty good. The y up top is y to the 1st. This is the same thing as y to the 1st times y to the 1/2, which is that. So the y is actually good. And then the x is going to be, that's x to the negative 2/3. And that is not that. So b is wrong. Wow, that's a tough cross out. So a and b are wrong. I'm not going to go through the other ones, but that's the way that I would recommend doing these, because in our heads, exponents are way simpler. We can conceptualize them better than we can with radicals, especially when there are multiple radicals and there are negatives with them and all of that. Put everything into exponents and be very comfortable with your exponent rules, and you should be able to do these problems without too much. It's not a lot of hard work. It's a little bit of brute force sometimes, but also, I mean, we got rid of this because it had no x, so it was very easy that way. Do you have any questions on that, Vic Sweet, or anybody else with getting radicals to exponents and all that? If not, we will move on.
Luotien, get a question about systems of equations here. They're looking for the coordinate pair that satisfies this system. So I'm going to just show you one method. There's two methods. There's 2.5 methods. There's substitution, there's elimination, and there's graphing. Graphing is not that exact, especially because humans are not perfect, but at least if we write math correctly and algebra, we'll end up with a perfect answer, kind of. So with substitution, you want to solve one of the equations for one of the variables. Right now, neither of these equations are solved for one of the variables because both of them have both variables on the same side. So I guess the simplest one that I would say to solve is the top one. There's no coefficients for the top one, or rather the coefficients are 1, so you don't really need to worry about them. I want to solve this equation for x, so the way to do that is to subtract y from both sides. All right, this is going to turn into x is equal to negative y. Once you've solved one of the equations for one of the variables, you can plug that in for that variable in the second equation. I'm going to take negative y, and I'm going to plug it in for where I see x in the first equation. Sorry, this is the second equation. This is why it's called substitution. You're substituting in negative y for x, okay? So when you do that, you're going to get the equation 2 times, now in parentheses, negative y minus 4y is equal to negative 18. Now pause. The reason why this is helpful is because we now have an equation that only has the variable y in it. There's only one variable, which means you can solve it. When you have an equation with two variables, the best you can do is solve for one variable in terms of the other variable. But once you have an equation with only one variable in it, you can actually solve it for that variable and expect to get a number, which is great. So solving this, we have negative 2y minus 4y is going to be negative 6y. And that's going to be negative 18. Divide by the coefficient, negative 6. You get y is equal to 3. So now you have 1/2 of the solution. The other question, or the other part of it, is what is the x value? Once you have one of your values, you can plug it into either equation, and your x value should be the same from both. It will be the same. The simplest one to plug it into is this one, because we already solved this thing for x. So if x is negative y, then x is going to be the negative of whatever y is, which in this case is going to be negative 3. So we're going to have negative 3, comma 3, and that is substitution right there. All right? Hopefully that made some sense. Levi, you want me to do the next one, or you got it?
I'm going to do Vix's next one.
Okay.
Thank you, too, for posting a bunch of questions, though. We really appreciate it. We have missed your questions, for sure.
Yes.
Oh, God, it feels so good to do this again. So, Vix, this one. X squared minus 2x minus 5 over x minus 3. When you have variables in the answer, this is a very common looking question. Kidnapped by Brendan. If Brendan did Brendan say he was just saying hi and then leaving, or is he in the chat still?
I'm gonna say he left the chat, but he didn't say where he was going. He probably has to inject some more trap essence into his traps.
That's very true.
He has to do that a lot to keep him up.
Yeah.
Kind of a poor guy
It's illegal.
in that regard. Is it though?
Yes.
Should it be?
Yeah.
Okay.
Everybody actually starts out my size, and then if they cheat, they get bigger. But I'm actually the
International standard?
Mm-hmm.
Like Legrand K, the kilogram that now no longer has a purpose? They redefined a kilogram recently, guys. It's pretty big news in science.
Did they really?
Excited about it. Yeah. It used to be a physical kilogram in near Paris that everything was compared next to, but they realized that it was slowly changing mass over the years, like decaying slightly, not like radioactive decay, but
Yeah.
So they just finally they have a way to connect it to Planck's constant, so that it's like a perfect scientific definition rather than like
that's
an
good.
actual kilogram somewhere in a museum.
Yay.
It's very exciting.
Okay. For this one, Vix. A couple of things you need to notice. They're asking you what this is equivalent to. So when it asks you that, you got to get from here to here, which you probably understand. And there are a couple ways you can do it. What I notice is that we have a fraction up top, and then we don't have fraction in these first two terms, but then we have the same bottom. We have this x minus 3 here, and we have it here, 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 and here. The first thing that I notice is that it looks like we just did polynomial long division, or we did synthetic division, and we have a remainder of 20, a remainder of 10, a remainder of 8, or 2. Or, sorry, negative 20, negative 10, negative 8, negative 2. So, Stan, maybe you want to read that, but, okay. So you could do polynomial long division here. You could do synthetic division here. Real quick, but it's not absolutely necessary. I think you do need to know how to do one of those for there can be a question, possibly.
You could choose your own value for x here.
Right, exactly. But do you have to know? I'm trying to think of a question where you have to be able to do polynomial long division or synthetic division. And I think it's only this type of question that it works perfectly for, but you don't have to for this. But is there a question on the tests? Either one?
On the SAT, might be one where it's like extremely helpful if you know how to do polynomial long division.
I'm going to do it first, and then I'm going to do it possibly an easier way. But this is the most straightforward way. So you start with x squared minus 2x minus 5, and you're doing division. So that's what we'll do here. I'm not going to do synthetic because it's a little confusing, although it's awesome.
Yeah, if you get it, synthetic is way faster than polynomial long division.
It's really quick and elegant.
Why don't you learn it then?
I do know it, but I don't want to teach it.
Oh.
Yeah. It just is a little nonsensical. At first, it seems that way.
I love it, though.
I know you do. Okay, so we're going to do this. So x goes into x squared, x times... What is the remainder theorem?
Yes.
The remainder theorem is something that you don't need to know for the test. They put it on one of the practice tests, and it helps for that, but you could still feasibly get the right answer without it. And it's really dumb.
I mean, I could write it out.
Yeah, you want to write it out and then maybe explain it?
Sure.
Okay, here we're doing division, so x times x minus 3 is going to be x squared minus 3x. 0, x minus 5 plus 1. So this is what we're going to get over here probably. 1 is x minus 3. So we just got x plus 1 with a remainder of negative 2.
You got a new streamer here.
Which means that D is our answer. Vix, does that make sense? Lamau Boyle. Is that Boyle? Boy. I thought I said Boyle. Boy. What is it? The Timmy Fairly Odd Parents
Timmy
Boyle
Turner?
kid? Boyle kid?
Stoop kid. Afraid to leave a stoop. Hey, Arnold. Different one.
No. There's a kid with a boil in Tim in Fairly Odd Parents. Right?
I remember the boil. Yes.
Yeah.
Yeah.
Anyway. welcome. Wait, so you are a streamer yourself, or you are watching us stream and you are new to our stream? Definitely new to our stream. Okay, so this is one way to do this, is just the straightforward polynomial long division or a straightforward synthetic division. You don't have to do that because, watching you, welcome, great. Sorry if I mispronounced your name. The other way to think about this is, if these are equivalent, then that means that it has to be equivalent for any value of x, because we're saying that x is a variable. I think they say that x does not equal 3 because they don't want to be dividing by 0, so that's fine. So any value of x aside from 3 has to satisfy this expression and the expression to which it's equivalent. Therefore, let's pick 0, because if x equals 0, that means whichever one is the right answer has to also have the same value for the expression as the given. So if we plug in 0 here, we're going to get -5 over negative. Okay, so it's just 5/3, positive 5/3. If we plug in 0 here, we're not going to get that, and you can do the same thing. So here, if you plug in 0, you get -5 minus 20 over 3, which is going to be a negative number clearly, so a doesn't work, right? So if you plug in 0 for x, they're not equivalent, so you can do it this way too. Now, just because, let's say b, we plug in 0 for x and we get 5/3, it doesn't mean it's the right answer. It just means that 0 doesn't make it wrong. You're confused on standard deviation. Yeah, we can do standard deviation. We have a couple things in the Discord, in the queue, that we haven't written up, but if you go into the Discord and ask a couple, but we will do some standard deviation. Thank you for saying please, Luo. We do appreciate that. Okay, I am done. You want to go through this quickly?
Yeah, of course. Yeah, if you take a polynomial and divide it by some linear factor x minus r, the remainder will be that polynomial evaluated with the x value of r. Okay? This doesn't really come up that often. The proof is here. I don't know if you've ever done polynomial long division, but you divide by some factor, you're going to get another smaller polynomial plus some remainder over that factor. You multiply everything by x minus r, and then if you evaluate it for that r, this part of it's going to go away because r minus r is just 0, leaving you with that the remainder was the polynomial with r as its input from the first place. So really quick, you have some polynomial p of x, and you're dividing it by x minus 5, and you're wondering, hey, what's the remainder going to be? The remainder is going to be p of 5. That's what it's going to be. It's not really that intuitive unless you kind of look at the way that it's proven, and it's like, I guess that's right, but like I've tried to wrap my mind around it, and I didn't really get very
It doesn't
far.
logically make sense beyond the proof.
There's got to be something I'm missing. I don't know.
It's not that important.
It is not that important. No, it is a very high shelf thing that you do not need to bring down that often. And if you do, you got to make sure that there's a tall person nearby. That's why I have Levi.
Yeah.
Okay, so the fish question, that's maximizing a function. So I'm gonna guess that they gave you the definition of a function that tells you how much money you're gonna make depending on how much you're going to sell. Yeah, wait, what grammar rules as well? Yeah, we've got that in the queue. Yeah, okay. The profit per pound of fish and the profit per pound of meat equals the total profit. That declares maxims like the highest amount sold of both products never exceed. Highest amount sold, right. Fish amount of meat, you're in the profit, profit. Yeah, okay, there's some kind of inequality. So profit is going to be equal to something like $5 times the number of pounds of meat plus $7 times the number of pounds of fish. Okay, so there's a different price for each, and you want to figure out how much of both you want to sell to make the most profit possible. But they're going to give you some other piece of information that is a restriction on how much meat and fish that you can sell in the first place. So like you said, the highest amount sold of both products never exceeds 200. Does that mean that both products put together, the sum, never exceeds 200, or each of them separately never exceed 200? I'm going to treat them like both of them separately never exceed 200. There's got to be some kind of... Okay, I'm gonna change that. I'm going to assume that it means that if you add the amount of meat and fish that you sell together, that can't exceed 200, which means it has to be less than or equal to 200. So that's an inequality there. That's got a bunch of different possibilities of what M and F could equal, okay? At their maximum, you could have M being 200 and F being 0. And that would still, this inequality would hold up. And then on the flip side, you could have your M be 0 and your F be 200, and then you have an infinite number of options between, of F being 197.2 and M being 2.8 and things like that. What you want to do is think about what gives you the biggest bang for your buck. Do you want to maximize the number of pounds of meat you sell or the number of pounds of fish you sell? Because fish, it fetches more profit, you want to maximize the number of fish that you sell. So if you have a choice here of which option you want to pick the one that maximizes the number of fish. Go all in on the fish. 200 pounds of fish, no pounds of meat. That's going to give you a total profit of 7 times 200, which is going to be 1,400. If you do the opposite, which is you maximize your meat, you have 200 times 5. That's only going to give you $1,000. It's not as much as 1,400. So yeah, biggest bang for your buck. Try to massage the inequality to create the best possible situation so that you get whatever situation you want, if it's the most meat or the most fish. Hopefully that makes some sense. See if you can find a question like that, and we'll go over it in a little bit after we go over some of this stuff. Yes.
Who in the chat is 450, 680 doesn't matter? Just so that I can address you better, because I don't like addressing you like that. I kind of want to just call you long hair don't care.
Yeah.
Which is just what your thing made me think of.
Long hair don't care.
Long hair don't care?
No.
No? Don't care? Long hair, but...
You got long hair?
Don't.
Short hair, care.
Yeah.
Long hair, don't care.
No, it is true.
Yeah.
Yeah.
No hair, where'd the hair go? You should look into that.
No hair,
Yeah.
press dissociate.
Yeah,
Yeah, it's good.
fine.
Right, good. Now, this is a survey question. And Long Hair Don't Care posted this, and you highlighted the right stuff. So you highlighted it's a pro football team, and the owner wants to see if the residents in the city will support raising taxes to pay for the new stadium. And then we have a couple of possibilities for how to carry out this survey. Let's see what we can get rid of, and I'm just going to go through all of them. So 300 students. Immediately, that's wrong. It says students. We don't want students. So A says students, and that's no good. We don't like that word because it's not representative. You always, for a survey, it's supposed to be a representative sample to give you a best estimate of what the actual outcome might be. You don't want to use students only to represent residents of a city in its entirety. That doesn't work. B, 300 residents, great. Okay, and 300 is the same for all of them, so whatever. Randomly chosen, good. We want them to be randomly chosen. From neighborhoods surrounding the existing stadium. So that is the specific thing here. So near the stadium. So it's going to be residents. Residents near stadium. Interesting. I'm not sure about this, because being near where the stadium will be built will definitely color your opinion. And depending on what type of person you are, it will color your opinion probably one way or another. Let's move on. Don't like it that much. 300 people randomly chosen from the team's mailing list. No. If they're on the team's mailing list, they probably are very happy to pay for a stadium. So mailing list is bad. And then D. We have 300 people randomly chosen from the city's list of registered voters. Okay. Now this is something specific, registered voters. One thing that you don't necessarily have to realize, but if they're not a registered voter, how can they possibly vote for raising taxes for the football team stadium, right? So I think that that's actually an additional thing that they added that makes sense. I don't like residents near the stadium because if you're near a stadium that's going to take 3 or 4 years to be built, you're not going to like that because it's going to be a lot of construction and all of that. So these questions do take some logic, and unfortunately, if you are not familiar with the logic surrounding football stadiums being built, you're at a bit of a disadvantage. But I do think that you can work through this problem. Students doesn't make sense. Mailing list is very, very clear. Residents near stadium, that's a little bit less clear, but I think a pretty understandable leap to make from here to say we don't want this to be done. Registered voters, that's fine. If they're unregistered voters, then they can't vote anyway, so why would you want to survey them? Okay, so that's this one. Let's see. It's almost 9. Well, no, it's not. It's 8:50. We could do another one of these. We could do an ooh question.
There's a grammar question that I can do.
Yeah, I'm thinking. Okay, you want to hop to grammar?
Yeah.
Ooh's question or something else?
Ooh.
Okay, we'll do this. Okay, we're hopping to grammar for Luo.
Okay, Luo, we're going to do your question first, and then we'll talk about more grammar rules in general. I'm looking at what you put on the Discord. It is a passage on the exploration of Cuba, number 25. And this is a interesting sentence here that I'm going to want to write up on the board.
You want me to write it?
Standard deviation. Say, well, we'll get to that. LMAO, boil.
It's up there. Don't you worry.
LMAO. LMAO. That's how you say that. Okay, so the sentence reads... You want to write it?
I'll write it, yeah.
Okay, well, here, you want to jump off? It's frequently doubtless navigators past.
Yeah, are you going to keep talking?
Yeah, I can keep talking. I just don't know what to say.
Okay.
Levi's going to write this out. The sentence as is says, frequently, doubtless navigators pass near its shores on their way to and from Darien and the Venezuelan coast, blah, 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 blah. The problem with the way it's written is the word doubtless seems to apply to navigators. Frequently, these doubtless navigators would do this stuff, okay? Doubtless is not meant to apply to the navigators themselves because it doesn't make sense that they're without a doubt. When we say doubtless, we mean it is a word that tells the listener or the reader that we know we're right. Doubtless, food is very important to people all over the planet. It's a word that means there can be no doubt about the statement that I'm making currently. It does not, at least in this situation, should not be applied to the sailors or the navigators themselves as an adjective. All right, that is the problem. You're fine right there. You can just start writing the answers. Okay, so no change is wrong because it seems like doubtless is applied to navigators, and that doesn't make sense. The next option, which Levi will be... I mean, should we write them out or should I just say them?
I'll write them out. You can start.
Okay. The next option is frequently navigators without doubts passed near the shores and on their way to the coast, blah, 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 blah. This is the same situation here, which is they're applying without doubts or doubtless to the navigators. And in this situation, it doesn't make sense that the navigators are without doubts. What are they doubting? They're not doubting anything. What it's saying is there were not a lot of people that visited Cuba, but it would make sense that if there were storms, sailors would probably moor there for the night to repair their ship and things like that, because that's just the kind of thing that happened in the age of sailing and Caribbean pirates and stuff like that. They're not all pirates. There's a lot of merchants and things like that. But that happened everywhere. If your ship is going through some storms, you want to pull over, it's kind of the equivalent of pulling over at a nearby island. So while Cuba was not an actual attraction that people were going to go see, it seemed like Hispaniola was taking the cake for that one. There's no doubt that navigators still probably went to Cuba sometimes just to stay and make sure that they're okay and rest up a little bit before they keep going on their trip. That's what they're trying to say. So navigators without doubts is the same problem. The navigators, the doubts should not be applied to them. Navigators, frequently doubtless, same situation here. That means that there's a lot of times where the navigators are doubtless. Again, it does not say what they're doubtless about. It's not meant to be applied to them having doubts. This one here is the answer. Navigators doubtless frequently pass, and it sounds not great. Doubtless is usually a word that you put in the beginning of a sentence. Well, how would you use this? I doubtless go to the market all the time. Doubtless I go to the market all the time.
This is a ridiculous question that you probably would not see on the test, is my guess.
Yes, in this case, doubtless does not apply to the navigators, even though it's right smack in the middle between navigators and frequently past. It's kind of almost like an interrupting element. Like, I would love to see commas around this thing so that it's a kind of an aside. So navigators, doubtless, frequently pass by, blah, 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 blah. But they don't have that.
Think about doubtless as probably. Or very in all probability.
Yeah. With 100% certainty.
The frequently is what makes it confusing.
Yeah.
If you get rid of frequently, it's a little bit clearer.
Yeah, navigators, doubtless, past. Makes sense. Good. All right, that's all we're going for.
Yeah. Yeah, that one's really hard.
Yeah.
For a question on the SAT or ACT. I've never seen anything quite that opaque before.
Difficult.
Yeah. Okay. I'm trying to fix my bad habits where I just circle what sounds right. Yeah, so, and everybody else, your gut feeling should never go away. You should always trust that at the end of the day. You know, that's what you should be trusting. But your first step is to do the rules. So all the punctuation should be pretty straightforward once you know the rules for those things, which we'll get to. And then there's some grammar stuff, and then you go with what sounds right. In that case, it's more or less what sounds right to you. That's what I would trust. If you know for sure, then great. But that one's really hard. I wouldn't worry about it. You're not going to get anything that hard and that unclear on the test. But yeah, you're going for what's right, go for the rules, and then point your gut feeling at the right thing. That's why you want to be identifying what question type you're dealing with, whether it's past tense versus present tense or commas or whatever it is, so that you can be thinking about the right thing when you're applying your gut feeling. But yes, your gut feeling is sort of a last resort type of thing if you got nothing else going for you. Now, do you want to do standard deviation now?
Sure.
Okay. Maybe there's a question. I don't think that was a standard deviation question. Would you like to do the standard deviation question?
I will do the standard deviation question. Is there an actual question, or is it just what is it and how do we use it and stuff?
No, there's no standard deviation question. We can just do it.
Okay.
And then we'll do punctuation stuff.
Got it. All right. Let's get a list of numbers up and running. Let's make them fun. Fun numbers. 1, 4, 5, 5. Oh gosh, 7 and 10. Okay. The mean, the arithmetic mean, is the average. You've done it a million times. You add up all the numbers, you divide by the number of numbers that there are to find out what the average value is of each number. Of all the numbers in a set, sorry. So if we have these together, we get 5, we got 15, 25, plus 7 is 32. 32 divided by 6 is going to be 32 divided by 6 is going to be 16 over 3, which is going to be 5 1/3. All right, the mean is 5 1/3. Just going to put 5.3. What the standard deviation is a measure of spread. It tells you how spread out the data is. So this data here is reasonably spread out. I guess that means nothing unless you compare it to another set of data. So I'm going to make another set of data for you. Let's say we had 4, 4.5, 5, 5, 5.2, and 6. Okay? I doubt this is going to have the same exact mean. If it did, that'd be kind of a miracle. But I'll figure out the mean really quick. That's going to be 4 plus 4.5 plus 15.2 plus 6 divided by 6 is 4.95. Okay. The mean of this list is 4.95. If I put this on a distribution, which is a graph that shows you how often certain numbers are, I guess, show up in the data, we get something like this. So this first one here, call this set 1. Set 1, okay, set 1. So I'm going to have a graph here that tells us the number and the frequency. Okay, so we're going to say we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We have 1, 1. We have a 4. We have 2 5s. We have a 7. we have a 10. Okay? Roughly here, in statistics, you get what's called a bell curve or a normal distribution, which is clustered around an average and kind of is like a approximation of the probability of getting certain values in a list. Okay? Clustered around the 5. The spread here is pretty significant if we compare it to this set here. Okay, it's going to look far more concentrated right in the middle. We're going to have something like this. So we have 4, 4.5. That should be the same height. Sorry about that. We got 2 5s. We have a 5.2, which is really close. We have a 6, which also is really close. These are all far more clustered around the mean. So the standard deviation is going to be smaller. So standard deviation is an indicator of spread. There is an equation to calculate the standard deviation. It's not important that you know that, but what it kind of is the average distance away from the mean that a point is. And it's not exactly that, but it's close to that. Okay, so this one here is 4.3 units away. This is 1.3 units away. This is 0 units away, 0 units away. This is 1.7 units away. And this is around 4.6 units away. Okay.
Wait,
so,
aren't, oh, sorry. Shouldn't 5 and 5 be 0.3?
Oh, yes. I'm sorry. It's not. Yeah, you're right. Good catch. Good catch. These are both 0.3. 0.3. So if you average all those numbers, you get the average distance away from the mean. It's close to the standard deviation, but it's not exactly the standard deviation. Okay. This is actually the absolute mean deviation, I think. And standard deviation is a little more complicated than that, but it's the same situation where it tells you how far apart the data is. So standard deviation of this list might be something like, I don't know, 2, maybe 1.5 or so. So that's one standard deviation. And then probably 2 or 3, something like that. Okay, it's going to make more sense if we actually do something to the data to show you how it changes the data. So let's talk about this first list. Let's just say that I added 5 to all of these numbers. What would that do to all the different indicators that you have in statistics? Okay, so first off, if all these numbers are 5 units higher, our average or our mean is going to be 5 units higher. If all the units are 5, if all the data points are 5 units higher, our range, which is going to be the distance from the top number to the bottom number, which used to be 9. If these are all now 5 units higher, this will be 15, that'll be 6. It'll still be 9. So the bottom of the list went up, but so did the top of the list. So the distance between them stays the same. The median will be lifted up as well. It's the middle number. The middle number will be lifted up by units by 5 units. The standard deviation, though, will not change whatsoever, because even though they've all been lifted up by 5 units, the distances between them and their spread has stayed exactly the same. So the standard deviation is not going to be changed by that. So if you just can think, large spread, big standard deviation. Small spread, small standard deviation. That is what you need to know for the SAT when they ask you questions about standard deviation. Levi, is that kind of the basic premise?
Yeah.
Probably went in some areas that aren't totally necessary to understand.
Yeah, and long hair don't care. The question that you just posted about standard deviation. Margin of error. We can hit that in a second. For standard deviation, if you have a bunch of numbers, if you have, here are your numbers, and you have that many, that many, that many, and that many, your average is going to be somewhere sort of in the middle of them, versus if you have that many, that many, that many, that many of the same thing, your standard deviation is going to be greater for, let's actually do another one. We have that, 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 that. This has the biggest standard deviation. You have a lot of numbers that are far away from what's probably the mean. The mean is about in the middle here, right, because it's pretty symmetrical spread. And a lot of numbers are far away from the mean, so therefore that standard deviation, which is the measure of how far all of the numbers are away in some way of aggregating that value, is going to be bigger here because those numbers are farther away. Here, it's kind of even across, so it's going to have a middling standard deviation, whatever that might be. And then here it's going to be pretty small because the numbers are clustered around what you would think is about the mean. So that covers standard deviation. You don't have to solve for it. You just have to be able to see how it gets changed and manipulated based on the data set. Okay, now let's do some punctuation, finally. And we're never doing math again for as long as we stream, right?
No.
You signed that paper, Brady.
No.
What is that? That's not good. Okay. What about margin of error? I saw that once on the SAT. Margin of error, they mention it sometimes. Margin of error is just how accurate your data is. You know, if you think the answer is going to be 50 with a margin of error of 2%, that just means you might be off by a little bit. They won't have you solve for margin of error. It's basically smaller margin of error is better, larger is worse, because then you might have a bigger error. I'm not sure what else they ask you with regards to that, but I'm pretty sure that's it. Margin of error is just how accurate are you being. You want to be more accurate, so a larger margin of error is better. Said that already. Now, punctuation. Let's start with sentence structure. Independent clauses. That is where everything lies. This is going to be an IC. An independent clause has a subject and a verb. And that's all it needs. It also has to be able to stand alone as a full sentence. Sorry about the squeak. Well, that's dead. That was cool. Okay, so Brady, give me an independent clause.
The bad man is good.
Give me a better verb.
Was good.
A different verb.
Dances poorly.
Okay. Now, I'm not going to get into that this is... Sorry if that was loud. I punched the thing. Poorly is an adverb. It doesn't really matter. Basically, what we have here is an independent clause. This is our subject, the bad man, and the bad man dances. So that's our verb. That's an independent clause. It can stand alone, right? The bad man dances poorly. Great. You don't have to say poorly, but it's part of it. Doesn't really need to go anywhere. You don't want to put a comma there or anything silly like that. This is an independent clause. You will always need to identify your independent clause. You can get stuff right without it, but it is the most methodical, safest way to figure out what your sentence structure is, and from there be able to work with commas and colons and semicolons and periods and dashes and parentheses and all of that. You need that subject and verb. Now, the tricky thing is when... Can you give me a blue, Bird? Very good. The tricky part comes in when we have something like unless. This is the last word from Dr. Seuss's book, The Lorax, actually, is unless. It's written on a tree stump. And what this does is it changes your independent clause to a dependent clause. If you just say, the bad man dances poorly, that can stand alone. But if you say, unless the bad man dances poorly, something else needs to happen, right? This depends on something else. Something's going to happen unless this happens, right? So you need other stuff. This cannot be a sentence by itself. It does this, it has the subject and verb. That's not good enough. It needs to be able to stand alone. Can't do that. The same thing as you say, I walk. I walk is a subject and verb. Great. But if you say, as I walk, Well, you need something else. What happens as you walk? It's not good enough by itself. So that's a dependent clause. It's very important to be able to identify when you have one and when you don't have an independent clause, and when you have a dependent clause specifically. You don't always have to be able to identify dependent clauses, but you definitely want to be able to identify independent clauses. When you see any punctuation, you have to identify your subject and verb. If you fail to do this, you are way, way, way more likely to make simple mistakes because you are misinterpreting what the sentence says. Identify what they are. You can actually go back to the reading section of the SAT or ACT, it doesn't matter, and read the sentences and identify where your subject and verb are in every single sentence. Also, you can have multiple independent clauses in the same sentence, so be wary of that. We probably won't get to that, but punctuation. Vix, you told me what you wanted to say. Okay, so sentence structure, commas and periods. Okay, periods, the only use of periods on the test, and not doing ellipses or anything weird like that, is just a period has to go at the end of a sentence. So everything before it, between that period and the previous one, has to be a full sentence, which could be multiple independent clauses thrown in with other things, but you need an independent clause somewhere. Same thing after the period until the next one. So periods are pretty straightforward with that, but you have to know this. Independent clauses. If you don't know independent clauses, then yes, periods can be very difficult. Then semicolons are the same thing. Semicolons, you have to have independent clauses as well. And then commas are the hardest, so I'm going to hold off on that for a sec. We're going to talk about separating independent clauses. So let's do this. The bad man dances poorly. Bird, give me a moderately related sentence to this, or independent clause related to this independent clause here.
Let's see. The good man dances very well. The good woman.
Good woman sings well. The bad man dances poorly. Okay, so you can have, oh, this is losing its luster. My goodness. You can have this. You can put a period there, Vix, or whoever else. The good woman sings well. The bad man dances poorly. That's fine. Oh my gosh, I am very sorry. I'm not used to this being here. Is that loud for you, Bird? Did you hear that?
But it's, it's whatever.
Okay. Very good. You can just say this. This is a little bit choppy, but whatever. This happens. This happens. The subject and verb here, here's your subject. And the verb here. What are you laughing at, Vix? Now, we don't have to use a period here. We can do something else. And I want to start writing down what the ways are to separate them. So this is separating or connecting, however you want to look at it, independent clauses. Number one is I see, period, I see. You can just do that. That's the simplest way. Next way is a semicolon. So you can do independent clause, semicolon, independent clause. That is the only use of semicolons that is tested here. So, ooh, I hope you're still here. You can put a semicolon there. If you can use a period, you can use a semicolon, as long as those ideas are related. If you can use a semicolon, you can use a period. So what that means is if you ever see two answers that have a period and a semicolon, and they're just changed between those two answers, and there's no other difference at all between the answer choices, they're both wrong. Okay? Good. Hello, Luo. Semicolon and period. These are the two easiest ways of separating independent clauses, and they're the two easiest pieces of punctuation because you only get one thing. You can only do one thing with them on the test. Now, you can use semicolons to separate items in a list with internal commas. You don't have to worry about that. You'll recognize if there's a list with semicolons, and I've never seen that tested. If it is, I will eat my hat, but I've never seen it. Semicolon, independent clauses on both sides. That is the only use of semicolons. Now, number three. The next way of separating independent clauses is I see, colon, I see. This doesn't really make sense in this context, so I'm going to write a different one. So let's say she sings well, colon, it reminds me of home. Reminds me of my childhood. Let's say that. So these two ideas are related. Wow, this is pretty dull. She sings well. It reminds me of my childhood. Both are independent clauses, and because they're related, and this one sort of expands on the first one, we can put a colon here. We don't have to. We could feasibly put a semicolon. We could feasibly put a period. I just want to put a semicolon or a colon here because you have this first independent clause idea, and then the second one expands on it, goes deeper, whatever you want to say. They sometimes will have you need to recognize the context part of colons, but a correctly used colon versus a correctly used period versus a correctly used semicolon, they will not make you choose between them. Sometimes you will have to recognize that a colon is contextually better, but grammatically, it's not an issue. Okay? So that is the third way of separating independent clauses. Now the fourth way is a little harder to recognize sometimes because it uses words, but it's going to be independent clause, comma, fanboys. Bird. What is fanboys?
Did somebody ask that?
I did.
Should I come up there?
If you want to.
I want to. I want to very much. The fanboys are the 7 coordinated conjunctions. For and nor, but or yet so. For and nor, but or yet so for. And nor, but or yet so for and. Nor, but or yet so. With a comma, they can separate it two independent clauses.
You have to have the comma. You always have to have the comma. You cannot separate two independent clauses with the good woman sings well, comma, nevertheless, the bad man dances poorly. You have to use a comma and one of these 7 words. If you do not have a comma in these 7 words and you do not have any of these and you do have 2 independent clauses, something has got to give. You need to change one of those independent clauses to a dependent clause. You need to get rid of it entirely. You need to shorten it and then make it a non-essential. You need to do something. But for 2 independent clauses, there are exactly 4 ways of separating them. Putting nothing in there gives you a run-on sentence. Putting just a comma is a comma splice. You cannot just put a comma. You can't do that. You never have the choice to do that. There is no choice there. You can't do that. Okay? So, those are the 4 ways of separating independent clauses. You have to be able to recognize independent clauses, but be wary of it not being an independent clause because it has an extra word like unless or as or while or instead of something. It can one of those things. That's called a dependent clause marker, or we call it that, and it tells you that you're not dealing with a dependent clause anymore. Okay. Questions on that, let me know. This is not necessarily a hard concept, but it's an easy one to forget about. When you see, and you should always be looking at the answers in the English/writing section first, the grammar section. You want to be looking at the answer choices to see what you're being tested on. If you see commas being messed with, colons, any punctuation whatsoever, find your independent clause or find your independent clauses in that sentence.
Destroy them.
Don't destroy them. Identify them.
Destroy
and
them.
then, no, don't destroy them, Bird. Bird. And that will lead you to where you need to put different things, okay? These are the ways to separate 2 independent clauses. This is an extremely common skill that you need for the test. Okay. Commas. I'm going to leave commas for another time because they're big and unwieldy. And we have about 10 minutes left. We did semicolons. We talked about all the uses of semicolons, all the uses of periods. It's just this. There is no other use on the test. Now, colons are a little different. You can use colons to separate 2 independent clauses, but what you really need for a colon is an independent clause, a colon, and then whatever you want. Can we do commas tomorrow? And essay? Yes, we can. To clarify, what essay? SAT essay, ACT essay, college app essay? What do you want? Independent clause, colon, whatever. So it can be an independent clause, but it can also be a dependent clause. It can be a single word. It can be a list of things. That's how maybe how you learned SAT essay. Okay, so we're just doing essays. We'll do all the essays. Yeah, we got to play some catch up because we haven't been on for a while. College app essays, yeah. Yeah. Okay, it seems like you are very much on that train, Vix. That's good. Independent clauses, separating them. Independent clause, colon, whatever you want. So you can say, give me a independent clause. Give me that.
Levi will never hurt Brady.
Levi will never hurt Brady.
Is that good?
I don't know.
Is that Brendan that's doing nerdish stuff right now?
No, that was me a while ago.
Got it. What would you guys do if I got into Stanford? If I get into Stanford? We'd be very excited. We'd probably do some sort of like a dance and song, like a choreographed number together. We'd send out notifications to all the people you're about to be surrounded by, just to tell them that you're coming and that they should be ready for you.
Yeah.
And yeah.
So-
You'll get one of the rings, and then we all put our rings together. We blast off.
Yeah. Oh, I need to find one. Levi will never hurt Brady. So that's an independent clause, and then we put a colon after that, and then I couldn't come up with a single word, so I just said they've made a pact. So that's explaining this part of Levi will never hurt Brady. So this is also an independent clause, and that's fine. We can separate them that way, and this is an independent clause. You could also say Levi... yeah, very good.
Yeah, that's about it.
You could feasibly set up what somebody says. You could say Levi says to Brady, or Levi talks to Brady, colon,
Levi will never
I don't love you, or something.
Yeah, right.
Yeah.
What?
Huh?
Levi will never hurt Brady, colon, ever.
Yeah, you can do that. That if you want to do that.
Not
Yeah.
necessary, but you could.
Yeah, that second thing expands on the first one. So we did colons, semicolons, periods, separating independent clauses, and what independent clauses are. The most important thing is what independent clauses are. That's what you need to practice and start recognizing. I would recommend going to the reading section of the test that you do and identifying where your independent clauses are, and if you can't, posting them in the Discord and asking where they are and asking what other parts of speech are going on. I would stay away from the old Englishy ones, because those can be very messy, and you won't really have one of those for the writing section or the English section, so don't do those. But anything that's a little bit more straightforward, identify what all those things are, and then as you get better with all the punctuation marks, identify what exact use of those punctuation marks you're dealing with. Yeah.
Hey, what time are we at?
We are at 9:22.
9:22. All right, there's a couple of math questions in there I could do.
Okay.
Yeah.
It's going to take me a while to erase this.
Let's see, there's one by 450, 460, doesn't matter, and there's also one by Luotian.
You can do long hair, don't care if you want. Luo's gotten a bunch of stuff today.
All right. Long hair, don't care. What is their little
I don't know. I asked,
Twitch
but they
handle?
didn't say anything.
All right. You got
I
a
don't
question?
know. They might not know that we're streaming, but that would be surprising. I'm sure they do.
Yeah, wait, who was that? Standard deviation person? Whoever is 480, 680 doesn't care. Can you say hi, raise your hand, and make sure that you're still on? Otherwise, we will not do your problem. I don't know. Crickets. We're hearing crickets. Because if they're not on, I could just go over to Loitien's problem. Which I might do. Oh!
Ah, that's who you are.
That's who you are. You are on. Okay. All right, El Mao Boyle.
Oh no.
Your question's about standard deviation. I'm going to guess that the misunderstanding came from the way that this chart is laid out, because it's kind of confusing. Standard deviation boy. SD boy. That's good. So I'm going to write out these two charts again. Over here. We've got Team A. We've got Team B. And we have two different columns. Number of goals and frequency. Frequency in this case tells us how many times did this data point happen. Okay? So we've got 0 goals, 1, 2, 3, and 4 goals. And then the number of times each of those outcomes happened. 4, 7, 5, 4, 5. So let's digest this for a second. This means that 4 times there was a value of 0 goals. So if I were to write out this data, it would look something like this. 0, 0, 0, 0. 4 zeros in a row. Next, we have 7 one-goal games. So that is going to be 1, 1, 1, 1, 1, 1, 1. You see how this is going? Okay. There are 5 two-goal games. So these are the actual numbers that show up on our data list, and these numbers tell us how often those numbers show up. Okay? So, hopefully that makes sense. If you think about what your average is going to be, because standard deviation is spread from the average, the most number of any singular data points we see is this one here. There are 7 ones in this list. Okay? So there is some kind of a cluster here. We have 4 and then 7 and then 5, 4, 5. This is a weird graph that I'm going to draw vertically. But this is kind of like the distribution if I were to orient it vertically. So this is the most that we see, which is 1. And then we see some 0-goal games, 2. Okay, exactly. If you look at... Oh, thank you. Thank you very much. Yeah, so there's the distribution, but seen normally. If you look at Team B, there is a massively huge cluster at 1 goal. There are 13 games where the outcome was 1 goal. So there's far more of a cluster around that, which means the spread is less. This has more spread. Team B has much less spread because their data points are all clustered around 13 to a pretty high extent. Therefore, the standard deviation of this list is much larger. The standard deviation of this list is much smaller. So the answer is going to be the standard deviation of the number of goals scored by Team A is larger, which you can already see because UWorld gave you the check on that, okay? This is big spread, big standard deviation. This is not a lot of spread, little standard deviation. That's what you got to have in your brain at all times. When you wake up on Saturdays, think about that. And other times as well. Going to sleep on Wednesdays. That's when I do it. I should be doing it more often, but for me it's...
Wednesdays is okay for you.
Wednesday nights, Saturday mornings is when I think about standard deviation. And that seems to do the trick.
Yes. And it's not that because... So you need to think about where the mean is.
Yes.
So the mean is not in the same place in A and B. The mean here, because this is pretty well spread and pretty even, is going to be around here somewhere because they all have the same number-ish of things.
If you got like a platter with a bunch of cups on it, you want to kind of try to balance them. So probably somewhere around here.
Yeah.
Somewhere in the 2 area.
But here, there's a lot of ones. There are 13 ones. And then there's only, this is 4 or 6 maybe. And then this is 3, 2, and 1.
That's literally so many ones.
It is so many ones, literally.
Keep going.
So,
Many ones.
our mean is going to be pulled because of this huge thing. It's going to be 1 somewhere. Very close to that. It's going to be just over 1. Maybe not. Yeah, it'll be just over 1. So, our numbers don't deviate from that so much because we have so many ones anyway. So most of our data points are right near the mean. So you have to think about where your mean is and then see how things compare to that. Lamau Boy, does that make sense?
Did boy? Oh, it is.
It is Boy. It's not Boyle.
Elmel Boyle.
No, boy.
Please let us know. This blue looks nice for now.
Thank you.
It goes away so fast.
When I get a cat, I want to name him or her Chairman Meow.
Yeah.
And I'm going to refer to her or him affectionately as, oh, looks like the chairman's hungry. Like, I'll very rarely bring out Mao, but I'll say a lot like, oh, how's the chairman doing? Like speaking to the chairman in the third person. I like the idea of that. Someday.
That's a good idea.
Put a little hat on him with like a red star. Be fun.
Okay. So,
he was responsible for a lot of famine in the 50s and 60s. A lot of people died. Not the Chairman Meow. Not the cat.
right.
No one should put a cat in charge of a country.
Although they would probably be responsible for a lot of famine in that case.
Yeah.
They were in charge of the country.
Well, how would you even like interpret what the cat wants? Just like what it puts its paw on?
Yeah, whatever it knocks off the table first or something.
That's a perfect name. Thank you. Yes.
Well, you got it. Send us a cat.
Yeah.
We'll bring it on stream.
Chairman Meow.
Okay. We are done for tonight. We are very happy to have this working again.
Extremely happy.
Should we tell them how we got it to work?
No. It's a secret. It's something we should have done a long time ago.
It's not our fault. At the end of the day, we're just really pissed, and monopolies are bad. So, pure
Except-
capitalism is bad.
Except for if you
But-
yourself are part of the monopoly.
Well, actually, no.
Really?
Yeah.
Oh. I would think if you're sitting on top of the monopoly, that's great for you.
Depends on what the monopoly is.
But
Like,
that
if you-
means that
if you have a monopoly on internet, that's good. But if you have a monopoly on selling baby socks, not as useful. And then you're encouraging other monopolies. Well,
family?
yes, we are family, but we need to talk to Brendan about it. We'll tell you, though. I don't see why we wouldn't, but maybe
Yeah.
Brendan has a good reason not to.
he's the lord of the traps. We got to run things by him.
Yes. Otherwise, yeah. So sharing is caring. So we are going to share with Brendan, and then we will share with you. But we'll tell you.
We can share over ASMR. That's what you want. Sorry.
Get out of here. Okay. Have a good night, everybody. We're going to do this stuff tomorrow. The commas and essays of everything. So, we'll see you tomorrow.
Someone's gonna
Hopefully, this is still working tomorrow.
Oh, it'll be,
Yeah.
hopefully. Yes. You like ASMR, huh? Where is Bob?
Bob is...
Not here.
Yes.
And that's all you need to know.
Bob went to NYU today.
He did.
Yeah, he went
Watch
to see
the
a
show.
show.
Yeah.
Good night.
Good night.
We are very happy to be back. We'll see you tomorrow.
That's you guys.
And Spectrum's in the corner crying.
Yes.
Actually, they're not. They're just, wiping their tears with their money, I guess.
Good morning. Okay, we're gonna go now.
Good morning. Good morg. Night. Yes. Good night, everybody.